Hi gang, you're hearing sound that is being sent from this laser communicator by laser beam to this photoresistor or photocell. In my first attempts the sound wasn't very good, for reasons I'll explain. But I've since found a simple improvement, and here's what it sounds like now. Here's a little more detail about how it works. The resistance of the photoresistor changes depending on the amount of light shining on it. The brighter the light, the lower the resistance, hence its name, photoresistor. Here I connect my meter to it to measure the resistance. You can see that with the light blocked, the resistance is in the hundreds of kilo ohms. But with this room lighting, the resistance goes down to just around 1.5 kilo ohms. Here's the circuit I came up with for receiving the communications from the laser. And here's the circuit diagram. It consists of the photoresistor, some batteries, an amplifier with speaker, and this resistor. The first thing I needed to do was figure out what value to use for that resistor. Doing so is a two-step process. The first step is to make some measurements. To hold the photoresistor in place, and to make it easy to aim the laser at it, I push the photoresistor through a piece of cardboard. Then I connect my meter to it. I find a clear radio station on the radio, and then connect the radio to the laser communicator's amplifier. I carefully aim the laser at the photoresistor. I watch what resistances the photoresistor has for different levels of light. The minimum is around 0.5 kilo ohms, and the maximum is around 1.5 kilo ohms. So, knowing those two resistance values, what value should I use for this resistor? The next step for finding a suitable resistance is to use something called the Axel-Benz formula, which is that the resistance should be the square root of the minimum and maximum resistances of the photoresistor multiplied together. Doing the calculation, I get 866 ohms. Finally, here it is all on a breadboard, and connected to the batteries and the amplifier and speaker. I tune in to a clear station. The crackling you hear is because the laser light is too bright for the photoresistor. It's saturated. One simple trick to fix this is to turn down the amplifier volume at the laser communicator, dimming the light. If it's not loud enough at the photoresistor, then the volume can be turned up there instead, since that doesn't have anything to do with the transmission. The result is a very clear sound. And then there's always fun playing around with it outdoors. Well, thanks for watching. Check out these other interesting videos too. There's one showing how the laser communicator was made, another on how the homemade amplifier in the jar was made, and for those new to electronics, one on how to read a schematic. And don't forget to subscribe if you like these videos, or give a thumbs up, share with your social media, or leave a question or comment below. See you in a bit.